Welcome back. In this lesson, we're going to learn that not all lava is created equally. You're going to have not just that there's different recipes for lava and different components in lava, and that lava can be runny and thick in different types of volcanoes, but also in the texture of the different rocks that we've looked at based upon how quickly or slowly that chemical or mineral cools out of the magma. Together, we're going to look at the different ways you can classify igneous rocks. So it's a combination, really, of the texture of the rocks along with the recipe or the composition of the rocks that help us to learn how to classify them. So in this first lesson, we're just going to look at what that means, and then we'll look at the different classifications in the next lecture. First, we're going to learn that igneous rocks, which make up magma and lava, are almost all silicates. So silicates is a silicon and oxygen molecule. So you have a silicon bound to oxygens and then bound to other silicons bound to oxygens, and then you have either a little tetrahedral, which is a little pyramid of just a silicon on the inside and oxygens on the out corners, like a pyramid, or you can form chains where they will stack together and form long chains, or you can form sheets or even three-dimensional structures. So you can end up having thinner and thicker silicates. So more complicated shapes, more three-dimensional shapes, or less can have to do with the amount of silicon that's in a rock. You're also usually going to have some kind of a stain. You're going to have different minerals in that, so you can have iron and magnesium and calcium and different things. And so depending upon what's in it and how thick it is, you're going to have different types of lava. And that will, eventually we're going to classify those on the thicknesses, how much percentage of silicon or silicates are in this lava, how thin is it, thin and runny, or how thick and gloopy will it be. Okay, so you're going to see that when they crystallize, you're going to essentially, the way they combine will form the two major groups of silicate minerals. So the two major groups are easy. There's a dark silicates and a light silicates. Okay, so dark silicates are usually lower in silica, and light silicas are richer or more abundant in silica. So higher silica content, which makes it thicker, are usually the light ones. And then dark silicates usually are lower in silica. Okay, so now remember, you can have all these other type of minerals in it that stain it. So you could have something like olivine, which is stained green, depending upon what is the mineral or what is the metal or what is the other element along with these silicate tetrahedrons are in this mineral that is making it this color or that color or its texture. Okay, so if you were to have almost all silica, you might have quartz. If you have lesser silica, you might have feldspars. And so these different classifications of rocks many times are simply on how much silica are in these rocks, lots and lots, or very little. We've already talked about how the texture can help classify a rock based upon how slowly or quickly that the minerals cooled in that rock. You're also going to see that the different compositions of the magma will determine what kind of rock you have. Based upon what's the stuff in that rock, you will have a different type of stone based upon its composition. So putting those two together, where you have the type of crystals because of the rate of cooling and the composition of the minerals involved, will give you a classification of the different types of rocks. And remember, too, that we're talking about igneous rocks here because anything that once was lava or magma is an igneous rock, and that comes from the word fire. So it's forged, if you want to think of it that way, in the fire, in the volcano. So here is a very useful chart of classifying igneous rocks. If you look on the left, you'll see that you have coarse grain, fine grain, porphyritic, glassy. So that's dealing with how quickly they cooled. Anything towards the top of this chart is going to cool slow. Anything towards the bottom would either be very, very quickly, or whether there's gas involved, like a vesicular, you would need some gases involved. Then the colors at the top, these mineral compositions, is based upon the amount of silica in it. So if you have almost pure silica, you would be on the left. If you have less and less and less, you would have on the right. And then you combine those two things where you're going to have the mineral composition of what's in it and how quickly that the minerals cool out and grow and the size that they grow. That is the classification of these various igneous rocks. So really, it's these two things put together. It's the texture of the size based upon the cooling, and the content of silica that would make one igneous rock from another.